All right, let's take a look at this question quickly. This is a question based on binomial expansion. Now, if we study this question carefully, we can see that the very first information we're given is that k is a non-zero constant. And we're told that this expression is equivalent to what we have right here. And the main question we have to find, or solve rather, is the values for a, b, and c. Now, this is quite simple, and the steps to take are quite very straightforward. The very first thing you have to do, since you were told that this expression is equivalent to this, so what you have to do is to try and find this expression on your own. And obviously, since they told you it was equivalent to what you have on the right, so you would then be able to match each of the values on the left hand side with the values on the right hand side. Let's take a look at how to go about that. All right, so as usual, I won't be doing the solving for the all the terms. I will just be giving you the final answer of what you're going to get while you're done with the expansion. But for those of you that are probably new, this is probably your first video, I would advise you to go to our previous video on binomial expansion. There you will see the methodology of solving this. So in order to expand this, all you have to do is to follow the binomial theorem and you will get your values. Now, in this particular question, the expansion for 2 plus kx all raised to the power of 6 will actually give you what we have right here, 64 plus 192 kx plus 240 k square x square plus 160 k cube x cube, and then it keeps on going. All right, so the reason why we're going to stop at this particular place is because you can see that the value on the right actually stopped at x raised to the power of 3. So it's not very necessary to continue at this point. Although if you want to do it just for the sake of doing it, it's still possible. You can go on to get the other terms, but we necessarily will not need it in this particular question. So looking at what we have right now, this is the expansion for 2 plus kx raised to the power of 6. Now we're told that this is equivalent to what we have right here on the right. All right. Now this means that if this was equivalent to this, that means we would not be wrong if we take our a. You can see right here. Look at this is the term without x. That means, and this is the term also void of x. So that means I'm very fine with concluding that a is equals to 64. We've gotten the very first value. That's actually quite simple. All right. Now, to get the next constant value, the value for b, all you have to do is to study what you have right here. If you look here, the coefficient of x was b, which was the same thing as the coefficient of x squared. So this implies that if that was the case, that means the coefficient of x here, which was 192k, must be equals to the coefficient of x squared, which is 240k squared, based on what we have here. So you can see coefficient of x here is b, coefficient of x here is 192k, and we're told that b was that of this and was the same thing as that of x squared. This means that the coefficient of x here, which is 192k, will also be equals to 240k squared. So this is the mathematical argument that will give us the value for our k. All right, we need, of course, if you wanted to get your b value, you need to know first what your k value would be. Looking at what we have here, we can go on to divide both sides by 240k. Of course, because we can see that we have the square of 240 of k here. So you divide by 240k, of course you'll be left with your k value here. So your k value is all that will be left on the right hand side, and that will be equals to 192 over 240, because k will cancel k also. All right, and this k here will cancel one of these, and 240 cancels this. So if you go on to solve this, you would end up getting a value of 4 over 5. All right, now we have successfully gotten our value for k. But don't forget, we were not even told at any point in time for us to find k. But k was very necessary in getting our b and c value. So to get our b value now, we can go on to use any of this expression. We can use 192k or 240k squared. Whichever one we use will give me my value for b, because they both represent the value for b. All right. So I will go on to use 192k. So since b was equals to 192k, I can then go on to write it as 192 multiplied by 4 over 5, since we've gotten our k value to be 4 over 5. And if you get this into your calculator, you get a final value of 153.6. All right, so that is your value for b. All right, now to get our value for c, go on to check what c represents right here. You can see c represents the coefficient of x cubed. You can see that right here, that c was the coefficient of x cubed. So you go on to find out the coefficient of x cubed right here, which is 160k cubed. So 160k cubed is our c. All right. So you go on to solve appropriately, raised to the power of 3. Now, if you solve this with a calculator, you get the final value of 81.92. So we have been able to get the value of our a to be 64, the value of b to be 153.6, and the value of c to be 81.92. All right, let's solve a different question entirely. All right, so looking at this question, we can see we are to find the value of k, but there is a condition we've been given. We're told that one of the term is 960x squared. This is key. This right here is key to getting a solution to this question. All right, now in an examination hall, you need to be very mindful of the use of your time, and that's one of the things we try to do right here, to teach you on how to economize the time rightly. Now, when they told you one of the term is 960x squared, one of the things that I know some students will want to do is to go on to expand this whole thing, and then they will go on to search for the term that looks like this, 960x squared. All right, you don't actually need to expand this whole thing. All you need to look at is the modality of the question. If you look at this question, we have 6 combination. I will avoid using the incremental value as k, because I already have a k as a term in this expression. So I will just use r as the incremental value. So generally, this is what we're going to do if we wanted to expand what we have right here. Again, if you have issues with understanding the theory of binomial expansion, I would advise you go to our previous videos. You would see us while we're doing the basics of binomial expansion. So this is the general thing we would have done if we were to expand this, and we'll be increasing the value of r ranging from 0 up until the n value, which in this case is 6. But you don't have to go on to expand all these things because we already know where we're going to. We're looking for the term that has x squared. So all I need to ask myself is what has to be the value of r that would produce x squared? If you look at the way this question, this expression is, you would understand that putting the value of r as 2 will actually produce x squared. So let's take a look at r being 2. So I would have 6 combination 2, k raised to the power 6 minus 2. I can split this up to minus 1 over 2. Of course, for those of you wondering what I'm about to do, if I have minus x over 2, minus x over 2 is the same thing as minus 1 over 2 times x. So I'm going to split it now. Of course, if there was a r here, I'll be going on to put the r for each of them. So I'll be having x raised to the power r. And now that I said r was 2, obviously, we'll be having 2 instead of r. All right, so you can see that this is actually what produced x squared. So don't forget, we're told that one of the term is 960 x squared. So you can see that the term that has x squared, here is it. If you go on to find 6 combination 2, you would have 15 times k raised to power 4. This will sum up to 1 over 4 x squared. Eventually, you'll be having 15 over 4 k raised to power 4 x squared. So now we've gotten the term that has the x squared. And from what we got, we can be able to get the value of k. Because you can see right here that when we were told that one of the term was 960, if they told us that one of the term was 960 x squared, look at, we have x squared right here. We have x squared right here. We have x squared right here. So you can see that this 960 will be representing 15 over 4k raised to the power 4. So we can go on to say that 960 is equals to 15 over 4k raised to the power 4. All right, so if you go on to solve this, you would have this. That's, we're doing the cross multiplication here. 960 times 4 gives us this, and 50k raised to the power 4 multiplied by 1. All right, so we have k raised to the power 4 being equals to 3840 divided by 15 will give us the value of 256. Then you have to go on to take the fourth root. The fourth root, I'm sure you get what we're trying to do there, of 256. You take off both sides. Of course, this will give you the value of k. And for this other side, the fourth root of 256 is actually 4. All right. So you can see how we were able to figure out the value of k using this detail we're given right here. All right. So we have the second question, determine the coefficient of x raised to the power of 3. Now, seeing that we have not done a full expansion of this, you have to go on with the same technique I explained while starting this question. So we don't have to expand the whole expression. All we have to do is for us to find the coefficient of x raised to the power of 3, you have to ask yourself that right here, what was going to be the value of r that was going to produce x raised to the power of 3? I'm sure you agree with me that the value of r should be 3. All right, so fixing the value of r being 3, of course, we have 6 combination 3, k raised to the power of 6 minus 3, then minus x over 2 raised to the power of 3. 6 combination 3 gives me a value of 20. k raised to the power of 3, then I'll be having minus 1 over 2 raised to the power of 3, then x raised to the power of 3. As I explained earlier here, you can see what we did right here. So this will obviously give me a value of 20. Don't forget my k now is 4. So I have 4 raised to the power of 3 multiplied by minus 1 over 8. Because minus 1 over 2 raised to the power of 3 will be minus 1 over 8. Alright? So if you go on to solve this, you will have 20 multiplied by 64 multiplied by minus 1 over 8. And obviously, you can see that the 8 goes here 1, the 8 goes here 8. Because 8 times 8 is 64. So we have a value of 20 times 8 times minus 1. This will give me the value of minus 160. Alright? So you can observe that this is the coefficient. Don't forget we had an x cube here, but we did not do so much on that because, of course, it was the coefficient of that we're looking for. So every other thing close to x raised to the power of 3, we call it the coefficient. So, and that was minus 160. So this right here is the coefficient of x raised to the power of 3. Alright guys, so we'll be going to more problems on word problems. We have some more questions to solve, but that will be in the next video. So guys, I hope to see you in the next video. Bye bye.